And obviously, if you have a slope and a starting point, we can calculate each intersection point here by just adding the delta x. And because we know where the manual y value is of this edge, of this edge of the polygon, we also know when we have to stop. Because when we have added it here 7 times, then the y value, where the y value is, and then it's the end of the polygon, the edge, so we know where to stop here. And yeah, so it's very simple. The reason why I'm making it such a detail here is that I often realize in exams that people make just very stupid mistakes. So for example, they forget when they're supposed to write down the edge table, or one entry of the edge table, they forget to write down the first entry of the thin line, which kind of indicates that, first of all, you can just forget about it when you're writing down in the exam, and that's of course annoying when you know it, and you just get forgetting very quickly because it's just fluffy. But a lot of times it's just an indication that people are just trying to memorize the algorithm, but are not really trying to understand it. And of course, if you don't have the index there, you're not able to reconstruct the edge of the polygon. So you always have to think about and making a table that represents the polygon, so do I have all the information there to represent the polygon? And if you don't write it down, it's an indication that you didn't really understand or try to understand it, just try to memorize it. That's a general thing that I want to highlight a little bit also with respect to the exams. Because there are, of course, especially in the second part, there are much more algorithms where you can just try to memorize and you get those exercises in the exam where you just have to execute an algorithm, you can get the full credit without really understanding it. But the problem is, like already last time, some people were saying, well, there's so much material in this course, but how can we all remember that, how can we all memorize that? And of course, I'm aware of this, I warned you about this at the very beginning, but the point is, if you're just trying to memorize it without understanding, you will have definitely problems. Unless you have a very, very good memory, it's just too much material. But if you're trying to really understand why are we doing this, why are we need, for example, a normal vector for implicit representation, why do we need two direction vectors for a parametric equation, or how is the parametric equation, how do we calculate the point of that, then it's much easier, of course, to also remember the formulas, and that's also why sometimes doing this stuff here is very easy. That's the algorithm is really simple, so I'm already wasting a lot of time with this, but hopefully I think you understand that this is important to really understand how it works, why it works, and not just memorize it. Yeah, so we have this way we present the edge table, the first edge. For the second, of course, we don't have to write it here because we already have it, but of course we already also need here the index. Then on the second scan line, we see another edge start, and then another one start, two start, and the fourth scan line, but in between there are no edges starting. So this is our edge table, and this represents a whole polygon in a way, of course, that makes it now very easily to do the scan line procedure to express those points that we really need for the drawing. And this is done by the so-called active edge table, which is then a modification of the just a development of the original edge table. What we say is, what we do here, when we move up with the edge table, we also record all the entries from the original edge table, but we modify then the entries in a way that we basically change it that we don't have the original starting point here, but we're moving basically intersection point up. And then when we see that we're at the end of it, then we remove it from the edge table because we're at the end of the vertex. So let's go through an example here which illustrates it. So we move to the next one, and then we add the delta x by delta x value.
遅れています西武新宿駅、隣駅、武蔵品川駅を3分遅れで発車しております。ご乗車ください。申し訳ございません。もうちょっとお待ちください。
Yeah, so let's go to the algorithm. So we start with the edge table, and the first entry, of course, there we just have 1 point. And then we move to the next one. So we say we want to represent this intersection point here now that we have here. And those are, of course, like you said, we just need when we move, when we add delta, increase delta by 1, we just need to increase, when we increase the y value just by this delta y equals 1. So we just add 1 to the y value, and we need to add this delta x, and we calculate this to the x value. So we take this x here, delta x, and add it to the original x value. So as the scan line number, or scan line number 1, of course, let's repeat that. 1, 8, 2, 7, and 1, 2, 8. Now I wrote it in a really bad way, so this is the scan line, and this here is the edge records that we have. Good. And now we're moving up to the next scan line number 2, and that means, of course, the y, the edge value doesn't change, of course, the delta x also doesn't change, but in this now you represent the intersection point, and of course, the y value changes by 1, which is represented by the scan line, and the x value changes by 2, 7, so we have here 1, 2, 7. And for the second edge, we have 9, because delta x is 8, 1 plus 8 is 9, the other two values, of course, stay the same. And we see here a third edge start here, from our edge table, we see that, here from the edge table, so we have here 9, 6, and minus 1 half. Now, we see here that for the second one, first of all, we see here that we have here an x value of 1 to 7, and an x value of 9, which is larger than 1 to 7, so we know here that these two are the borders of our polygon, and this one also starts at 9, so we know that there is no more coming, but it starts here. Of course, there will be more coming in this case, but here we just have these 3, so we have these two x values, so we know, of course, that these are the ones that we have to draw. So these are the pixels that we have to draw. And the other thing we see here is that here, the y value and the scan line value are the same, and the scan line value represents the y value of this intersection point. So we see that the intersection point is already the end of this edge here, so in the next step, we remove this edge here, this entry here. So in the third scan line, we again have this here, so we have 2, 4, 7, we have 8 and 2, 7 here, and then we have here, we reduce this because it's a negative slope here, so we have 8, 1 half, 6 and minus 1 half, and that one disappears because we're at the end of the edge, so we know which one we're drawing these points in between, and then we continue like this. For instance, here of course we have the different situation because we have a new edge entry here, so here we have 3, but because we have this one twice, we see that here another part of polygon starts, and here of course we have the full edge segment, which we can see if we are sorting, of course, our edge record by the x value, which is